Test test, 1 2 test test. All right, perfect. But before you get started, let me hit one more thing. Anyways, welcome back to another midnight calculus session. Today we're finishing off where we started yesterday, and we're gonna do trigonometric substitution. All right, let's see. See if I can get this going. 7.2, we did it out of order. Let's put on some music and let's see what I can do. We got quite a few problems. 1 second. The first problem is going to be number 3, which wants us to find the integral from 0 to pi over 2 of sine to the 7th power theta times cosine to the 5th power theta d theta. Alright, two ways about this. Because the power of the cosine is lower, I'm gonna take the easy way out and say this is equal to the integral from integral sine 7 theta times cosine squared theta squared times cosine theta d theta. Then I can say this is that integral from 0 to pi over 2 of sine 7 theta times 1 minus sine squared theta squared cosine theta d theta. Now we can do a u sub. U is equal to sine theta, therefore du is equal to cosine theta d theta, which is perfect. Then we would have the integral from somewhere to somewhere of u to the 7th power times y minus u squared squared du. Solve that, we get u to the 7th power times 1 minus 2u squared plus u to the power 4 du. That turns out to be integral of u to the 11th power minus 2u to the 9th power plus u to the 7th power du. Integrate that, we get 1 over 12. Oops. Or tau u to the power of 12 minus u to the power of minus 2 over 10, so 1 over 5 u to the 10th power plus 1 over 8 u to the 7th power, if that's right. Plus c, but I'm not gonna include plus c for now. From summer to summer. Plugging or numbers, we get 1 over 12 sine theta, sine to the power of 12 theta, minus 1/5 sine to the power of 10 theta, plus 1 over 8 sine 7 theta, from 0 to pi over 2. Now if theta is equal to 0, then everything's just 0 because sine of 0 is 0. So now we only want to plug in power of 2. Sine of power of 2 is 1, which is convenient. Wait, is it? Yeah, sine of power of 2 is 1, so we get 1 over 12 minus 1 over 5 plus 1 over 8. I guess we'll simplify a bit. LCD would likely be, I'm gonna guess 120. LCD of 12, 5, and 8 would be 120. So we got 10 minus 5 times what? 12? Wait, no, 20, 24. Right? Yeah. Plus 15 over 120, which is equal to 1 over 120. And that would be, this is number 3, 1 over 120 is correct. Now once we're done with 3, we're moving on to number 9. Number 9 wants us to find the integral from 0 to pi of, this is the right question, of cosine to the power 4 2t dt. I don't like this question as much, but we can still rewrite it as integral from 0 to pi of 1 minus sine squared, or rather, I think there's a better way about this, of cosine to the power of 2t squared. So that would be integral from 0 to theta, no, 0 to pi of 1/2 of 1 plus cosine 4t squared dt. This is right? This should be positive. I think it should be positive. I believe it's positive. Keep doubting myself. But anyways, if we factor out 1/2 squared, we would get 1 over 4 from 0 to pi of 1 plus 2 cosine of 4t plus cosine squared 4t dt, which can be rewritten again because we don't want the cosine squared. We want the integral from 0 to pi of 1 plus 2 cosine of 4t, not theta, plus 1/2 1 plus cosine of 8t. And close out parentheses. Why are my parentheses always weird? Alright, that's that. Now let's simplify. Have integral 1 over 8 times integral of 0 to pi of 2, or rather, let's say 3 plus 4 cosine of 4t plus cosine of 8t dt, and that would be possible to integrate now. It's from 0 to pi, 1 over 8 times that. Wait, no. We can integrate now. No need to do that. 1 over 8 times 3t plus sine of 4t plus 1 over 8 cosine, no, not cosine, sine form a sine of 8t. And we want all that from 0 to pi. Well, sine of pi is 0, sine of 0 is 0, so that would be 3 pi over 8. And this is number 9. That is correct. Answer is 3 pi over 8. Once we're done with 9, we gotta move on to 11. 11 wants to know the integral from 0 to pi over 2 of sine squared x times cosine squared x dx. Now for this problem, we would still need to use our, I think what's called double angle theorem. So that would be integral from 0 to pi over 2 of 1/2 1 minus cosine of 2x, not plus, times 1/2 1 plus cosine 2x dx. So that would turn out to be 1 over 4 times the integral from 0 to pi over 2 of 1 minus cosine squared x. No, cosine squared of 2x. Uh-oh, lag. Why does Microsoft Whiteboard perform so poorly? I know I have a lot of writing, but considering the specs of my computer, I would expect the whiteboard to perform better. It would be great if they have something like lazy loading, or it doesn't load the entire board. So that way, wherever you're looking at has better performance. Anyways, where was I? Not talking about whiteboard. If I get distracted, I suddenly forget everything I'm doing. So now that we have that, we need to do another double angle. Write our integral. This is 1 minus 1/2 times 1 plus cosine of 4x dx. Simplify that. 1 minus 1/2, that is 1/2 minus 1/2 cosine of 4x dx. Simplify that again, we get 1 over 8, 0 to power 2 of 1 minus cosine 4x dx, which is simple enough to solve. So we get 1 over 8. Oops, keep accidentally doing that. And more lag. Fantastic. Please erase. 1 over 8 times x minus 1 over 4 sine 4x from 0 to pi over 2. Now sine of 4 pi over 2 is 0. Sine of 0 is 0. That leaves us with 1 over 8 times pi over 2. So pi over 16. Let me draw the box a little bigger. It can get blurry when I export it to PDF. This was number 11. Number 11 is pi over 16. Perfect. We got that one right. Now that we're done with 11, let's move on to number 13. Number 13 wants to know the integral of the square root of cosine of theta times sine cubed theta d theta. I think I have an idea on how to solve this one. So let's do, well, this is an indefinite integral, so let's rewrite this as the integral of cosine. Rather, let's not do that right now. Oh god, even the undo order is wrong. Cosine of theta. Please, I just want to undo. Square root of cosine theta times 1 minus cosine squared theta times sine theta d theta. Now we can do u is equal to cosine theta. Correct the little du is equal to negative sine of theta d theta. Alright, knowing that, we can rewrite this as integral of u to the power 1/2 times 1 minus u squared du. Of course, negative, because this is negative sine theta. Now rewrite that again, we get integral of u to the power 1/2 minus u to the power of 5/2 du. So let's factor in the negative. We get integral of u to the power 5/2 minus u to the power 1/2 du. Now we can factor it. This is 2/7. Why did I write the integral sign again? This is 2/7 u to the power 7/2 minus 2/3 u to the power of 3/2 plus c. You know what, let's do write the plus c because we'll, let's not. Doesn't matter, but looks cleaner this way. Now plug in or u again, 2/7 cosine to the power 7/2 theta minus 2/3 cosine to the power of 3/2 theta plus c. That is number 13 is correct. Now that's 13, let's move on to 15. 15 wants to find the integral of cotangent x times cosine. Why does this keep rotating? Cosine of cosine squared x, not theta, dx. And it's an indefinite integral. This one quite tricky. We have a cotangent and a cosine. How would I go about doing this? Oh, I know. Let's rewrite this. This is integral of cotangent x, or rather, instead of cotangent, let's write cosine x over sine x times 1 minus sine squared x dx. Now that's solvable. So we take the integral of cosine x over sine x minus sine squared x over sine x dx. And that cancels out, so we get the integral of cosine x over sine x minus sine x dx. Undo, please stop lagging. I tried a few other whiteboard apps, but I can't really say I like any of them better than Microsoft Whiteboard. I tried out stuff like OpenBoard, but OpenBoard forces you into full screen, and that entire Windows just behaves weird. Anyways, where were we? Right. Derivative of sine x is cosine x, so this is 1 over u du. Therefore, this is equal to the natural log of sine of x minus or plus cosine of x. Because integral of negative sine x is cosine of x. Plus c. Can't forget the plus c. Anyways, 15 is not correct. Finally got a problem wrong. The natural log sine x part is correct, but we did something wrong in the second part. What so? Oh my god. The entire application is just not responding now. 1 minus sine squared x. Cotangent is cosine over sine. Oh, I see. I forgot something here. I forgot to factor in the cosine. The sine squared x cosine x over sine x dx. Therefore, this is integral of cos x over sine x minus sine x cosine x. And if I remember right, what was that formula again? Okay, whatever. We do not need it. Dx. Integral of cosine x over sine x natural log sine x. Of course, we need to include absolute value. And derivative of sine is cosine, so this is u du. Therefore, it's 1/2 sine squared x if sine x is u, and cosine x dx is du. And then plus c. Alright, number 15 is now correct. Once we're done with number 15, let's move on to number 23. 23 wants to know the integral, the indefinite integral of tangent squared x dx. Okay, this is actually a really easy one, because tangent squared x is equal to 1 minus secant squared x minus 1, right? Yeah, that's right. Dx. So now we get the integral of secant squared is tangent, and the integral of 1 is x. And that's it. 23 is, yeah. Why did they throw in such an easy question? That one was easy, but our next competitor, number 25, will not be as easy. Number 25 wants to know the integral of tangent to the power of 4x secant to the power of 6x dx. Indefinite integral once again. Let me think for a moment. How are we gonna approach this problem? I think I know. Let's keep tangent for x-axis, and then we're gonna take out a secant squared x because the derivative of tangent x is secant squared x. So this is gonna be 1 plus tangent x, tangent squared x squared secant squared x dx. Then we're gonna do a u sub. U is equal to tangent x du is equal to, or secant squared x dx. So that cancels out perfectly. We get the integral of u to the power 4 times 1 plus u squared du. Simplify that. We get u to the power 4 times 1 plus 2u squared plus u to the power 4 du. And we get integral of u to the power 4 plus 2u to the power 6 plus u to the power of 8 du. Easy enough to integrate. We get 1 over 5 u to the power 5 plus 2 over 7 u to the power 7 plus 1 over 8 1 over 9. Oh no, not the lag again. 1 over 9 u to the power 9. Microsoft Whiteboard could really use some improvements. I'm still trying to find another whiteboard app that would be better for this. Anyways, yeah. Now we gotta plug our u back in. We get 1 over 5 tangent to the power of 5x plus 2 over 7 tangent to the power of... not the lag again, please. Minus 2 over 7 tangent to the power of 7x plus 1 over 9 tangent to the power of 9x plus c. Now I'm questioning whether or not I wrote plus c for every other problem before this one. And that I did. Anyways, this was number 25. The number 25 is correct. If number 25 is correct, we can now move on to number 29. 29 wants to know the integral from, the indefinite integral of tangent cubed x times secant to the power 6x dx. Well, isn't this just the exact same problem as the last one? This is basically the exact same problem, except instead of u to the power of 4, we get u to the power of 3. But even though it is the same problem, let's just write it out again, because why not? We basically have the exact same thing as the previous problem. U is equal to 10x. I feel like my writing's just getting smaller and smaller over time. Is that happening? Anyways, du, sure enough, is equal to secant squared x dx. So then we can rewrite our integral as u to the power of 3 times 1 plus u squared du. And we're just gonna take from number 25, and this is going to be equal to the integral of u to the power of 3 plus 2 u to the power of 5 plus u to the power of 7 du. Exactly the same thing as this, but 1 power lower. There we go. Then we get 1 over 4 u to the power of 4 plus 2 over 6, so 1 over 3 u to the power of 6 plus 1 over 8 u to the power of 8. That is going to be equal to 1 over 4 tangent to the power of 4x plus 1/3 tangent to the power of 6x plus 1 over 8 tangent to the power of 8x plus c. And this 29 is correct. If 29 is correct, we can now move on to number 30. What? Oops, not this color. 31 would like to know the indefinite integral of tangent to the power of 5x dx. Now I need to think about how I'm gonna do this one. If I were to guess, we would have to do secant squared x minus 1 squared times tangent x dx. Is there a better way to do this? Feel like there's a better way to do this that I'm not getting. But what else can we do with tangent aside from turning to secant squared x minus 1? So what if we get secant to the power of 4x minus 2 secant squared x plus 1 10x dx. But we would need to deal with the secant to the power of 4. Hello, wait, am I not getting messages? Oh, alright, NPC gone wild. Welcome to calculus. We're currently struggling with tangent. Tangent. I am doing fine. I don't know how long I've been without sleep, but I am fine. Your brain works better when you don't have sleep. Haven't done integration in a long time. I just question if there's a better way to do tangent right now. I'm pretty sure there was an easier way than this. Or is there? Oh. Hello, Holo GSD. Braze works better when supplemented by MATLAB. What is that? MATLAB. Ooh. It looks cool, but I still don't know what it does. Oh. Wait. This is cool. Maybe I could use this. MATLAB? This is cool. So it's called stuff like graphs. What else has it got? You always did tangent like this? I thought there was some easier way to do this. Or maybe we did learn about an easier way to do this in class, but I do not know. Okay. Let's see. Alright, we'll just do it this way then. You come to lean on computer algebra systems a lot. I don't know much about computer algebra systems, but I know that calculators are capable of solving these integrations. Let me actually, I think I have an idea to try out. We start from here. What if we do the same thing we do with secant and we just say u is equal to my eraser. U is equal to secant x. But then du is equal to secant x tangent x. Dx. Wait. Tangent x dx would be equal to secant x. Oh god, I just wrote something terrible, didn't I? Every time I try to write a trig equation or trig identity, trig function something, there's 3 letters, I forget one of them. Like I just finished thinking about it and I just write down the x. And I forget about one of them. I forget about one of the letters being there completely, and that can lead to some pretty hilarious results. So tangent x dx is equal to, but that wouldn't really work out, would it? Or rather 1 over secant x. Wait a second. Wait a second. Secant x is u. That means tangent x dx is equal to 1 over u du. Wait, how would I use this? Oh, I think I know. I think I figured something out. This might be a better way to solve this equation. I have no idea whether or not it will work, but it's worth a try. So we get u squared minus 1 squared times 1 over u du. It wasted this TikTok video solving simple exponentials. Wow. Or calculus is reaching TikTok too. It's no longer limited to YouTube and Twitch. The influence of calculus is spreading. What do they do that make you mad? Did they do something really dumb? So get u to the power 4 minus 2u squared minus 1 or plus 1 over u du. And then we take the integral of u to the power 3 minus 2u plus 1 over u du. So that is equal to 1 over 4 u to the power 4. He did the solution wrong. Minus u squared plus natural log of u. Okay, if I'm streaming and I get the solution wrong on a question, I'm kind of okay. I'm still trying things out. I will try to fix my problem if I find that the solution is different from the textbook. But if you're posting a video, you probably had the time to review it before you post it. So that would be a problem. Misinformation. We get 1 over 4 secant to the power 4 x minus secant squared x plus natural log of secant x plus c. Oh my god. If this is the solution, have I found an exploit to mass? Oh, is this it? Is this it? Oh my god. Wait. No. No. Something's wrong. No. No. I thought I figured something out. Ah. Something's wrong. This is not supposed to be secant squared. In the answer, it's tangent squared x. So now it's time to figure out how they got to that. Just double checking. 1 over secant squared x minus tangent squared x plus natural log of secant x. Alright. If they get the solution wrong on a video, downvote it. Unless they remove the downvote button like YouTube did. Maybe I simply need to simplify, but how did that secant squared x turn into tangent squared x? I don't think there's anything wrong with my logic over here. Tangent x dx, that's what we have here. Is equal to 1 over u du. Maybe this is not allowed? No idea why that wouldn't be allowed though. U squared minus 1. Yeah. Yes. What could I have missed? Yeah, that is the wrong keybind. There's the right one. Now I can do this. How does it get tangent squared x? 1 over 4 minus u squared. If I turn that into 1 plus tangent squared, that wouldn't work either. How? The answer is Integral of tangent to the power of 5x. I did not write the problem wrong. That's happened a few times before. How does it get tangent? I'm in pain. I've double checked my work twice. I don't know how they got the tangent. I'm checking the solution in the textbook. This is the solution provided by the textbook. And it says instead of a secant squared x, that should have been a tangent squared x. Or maybe I should cast it. Because I know textbooks do occasionally get the answer wrong. Alright, time to cheat. Let's cheat. Because I honestly don't know what I did wrong. I think I was right. I think the textbook has a problem. Yeah, I think the textbook has a problem because this is what the cast tells me. This is the same answer as the one I have. Alright, we're fine. Textbook has me confused. Let's leave it as that. That was so much time wasted because the textbook was wrong. So this works, but I thought I was smart for figuring this out, but then the cast did the exact same thing. And I thought I was smart for figuring out a quicker way to solve this. Anyways, the next problem looks positively horrifying. The next problem we're gonna do is 37. 37 would like to know the integral of, or rather is the integral from pi over 4 to pi over 2. Yeah, I had no idea this would work, but it did. That's some very good shortcuts to take. We got cotangent of 5. I don't know what to call this thing. It's a circle with a line through it. It's like a theta, but someone stabbed it with a knife. And now it's just dead here. And I don't know what to call that, so I'm gonna just say it's X. I don't think I'll get points off for that. I'm just... Phi! That's what it's called. I was thinking of psi, which was that thing. So that's psi, that's phi. You need to know a bit of Greek to do calculus. Or is this even Greek? I think it's Greek. Don't quote me on that. I'm no language expert. So, wait, I have the entire color wrong. We use phi to denote phase shift. I don't think I know about phase shift yet. Is that part of calculus? Actually, I think I've seen it in a textbook somewhere in a later chapter. We want integral, integral from pi over 4 to pi over 2 of cotangent to the power of 5 psi or phi times... Yeah, if you're doing engineering, they got quite a few things to do with math. cosecant cubed phi d phi. All right. What I want to do is probably make all these even. I'm going to rewrite the integral first. From pi over 4 to pi over 2 of cotangent 4 phi times cosecant 2 phi times cotangent phi cosecant phi d phi. Get down here. I'm busy. I never use math this complex either, but I will say quite a few things that I've done in math came in handy when I'm doing programming. Especially since I was working on a game and we had to do rotations, so Euler angles came in really handy. Anyways, if I remember right, 1 plus cotangent squared x equals cosecant squared x. We basically never work with cotangent and cosecant, so I'm kind of estranged with these two. I will praise that I'm right. We get power forward, pi over 2 of cotangent 4 phi times 1 plus cotangent squared phi. Cotangent phi, cosecant phi. Oops, take my eyes off and my writing turns squiggly. D phi. I don't think I can even read my own writing at this point. But anyways, now we can do a little u sub. U is equal to cotangent of phi du. Wait. No, because that would want cosecant. Wrong thing, wrong thing. Redo, redo. We need to do it the other way around. We need to change the cotangent, not the cosecant. We take the integral from pi over 4 to pi over 2 of 1. No, not 1 minus. 1 minus for science. Undo, please. Microsoft Whiteboard is really laggy today. We get cosecant squared phi minus 1 squared times cosecant squared phi times cotangent phi cosecant phi d phi. Stream's choking up too. Yeah, I had some people tell me that the stream was buffering up a lot on mobile. They were fine on PC, but just mobile. So I haven't been able to figure out, is that my internet's problem or is it just Twitch acting up? Or maybe just the mobile data. Anyways, now that we have this, we can do a quick u sub. U is equal to cosecant phi du is equal to negative cotangent phi cosecant phi d phi. And that would net us negative integral from somewhere to somewhere of haven't really used mobile Twitch, so I can't say much about it. Well, we got u squared minus 1 squared times u squared du. That would net us u to the power of 6 minus 2u to the power of 4 plus u squared du, which in turn turns into negative 1 over 7 u to the power of 7 plus 2 over 5 u to the power of 5 plus, no, not plus, minus 1 over 3 u to the power of 3. Plug in or u, we get negative 1 over 7 cosecant of 5 to the power of 7 plus 2 over 5 cosecant to the power of 5. Why does my 5 look so much like a 3? 5 and plus, not plus, minus 1 over 3 cosecant to the power of 3 phi plus c. And then we circle all of that. And yay! That is number 37. Let's check our work really quick. 37. Wait. I just forgot something really important. I can't believe I just forgot that. This would ruin my grade on the exam, because this is definite integral. I completely forgot about that part for some reason. From summer to summer. Ooh. Cosecant power 2. Oh god. So sine of pi over 2 is 1. 1 over 1, that's negative 1 over 7 plus 2 over 5 minus 1 over 3 minus sine of pi over 4 is root 2 over 2. Seriously? I have to do this? Oh, please, no. Please. I don't have a calculator. Have mercy on me. I guess we just have to solve this. First part's bad enough as is. LCD. It's gonna be all the multiplied together, so that's negative 15 plus 42 minus 35. Oops. All over 105. Minus. Ooh. I don't like this. 2 to the power of 7 times 2 to the power of 3. This would be 2 to the power of 4 over root 2. And this would be 2 to the power of 3 root 2 minus 1/3 2 to the power of 2 root 2. Ooh, we're running out of space. So that's negative 8 over 105 minus let's take the 2 out. Negative 4 over 7 plus 5 minus 1 over 3 times 4 over root 2. If we multiply by root 2 on top and bottom, that would be 2 root 2. Root 2. Minus 20. We're gonna have to, oh no, multiply by 15. Let's do this a long way. 15, 60, 5 times 21, 105. Wait, no, 525 minus 35, and that would be all over 105, and that's going to multiply by 2 root 2. Negative 8 over 105 minus, that's 94, no, 95, 90, 70, 530. Which would be, this is definitely wrong. I can feel it. When we have an answer this long, it's definitely not correct. So let's check. This was number... yeah, you never really know where you go wrong. You would have to go through the entire thing again. This is 37. The answer to 37 is 22 over 105 root 2 minus 8 over 105. So, yeah, wrong. But some part of it looked kind of correct. So where did it all go wrong? Oh, I see it. I see it. Why did I write 5 over 2? This is not 5 over 2. This is in fact 2 over 5. If that's 2 over 5, this would be 4 over 5. It would be 4 times 21, that's 84. Now that would be 95, 84, 11. Negative 11, so that's a plus, which will lead us to yeah, 22 root 2 minus 8 over 105. So that was just a really dumb mistake on my part for writing 2 over 5 as 5 over 2 instead. Otherwise, it's correct. Alright. Now that we've done 37, need everything to line up perfectly. We can move on to 41. Wants to know the indefinite integral of sine of 8x times cosine of 5x dx. Now, I forgot what it's called. I think this is called the half angle or angle sum theorem, something theorem. I cannot remember names. Like, if it's a name, I will not remember it. But I do know that this is equal to 1/2 of sine of 8x minus 5x plus sine of 8x plus 5x dx. If I remember it right, that would be equal to 1 over 2 of integral of sine of 3x plus sine of 13x dx, which would simply turn out to be 1/2 times 1/3, or rather negative 1/3 cosine 3x minus 1 over 13 cosine 13x, which would turn out to be negative 1 over 1/2 cosine, or rather, 1 over 3 cosine 3x plus 1 over 13 cosine of 13x. If you remember the identity, not that difficult, right? Oh, plus C, plus C. Did I write plus C for the other answers? Every single time I realize that I forgot the plus C, I need to go check every single answer I've written before that to make sure every one of them has a plus C. It's a paranoia at this point. Right, 41 is... if we factor it out, it is correct. Fantastic. That was another easy problem, 3 points for us. But next up, we shall have number 45. 45 would like to know the integral from pi over 6, from 0 to pi over 6 of 1 plus the square root of 1 plus cosine of 2x dx. I kind of recognize this. But I feel like I have C is a paranoia for everybody. Right. There's a C and then there's a natural log with its absolute values. Those two things, you realize you forget them and you need to go through every single problem you've done so far. And Microsoft Viper's not responding again. I'm gonna need to write this out. Cosine squared x equals 1/2 1 plus cosine of 2x. Never mind, I don't have to write this out. We just multiply by 2. Okay. So I can rewrite this as integral from 0 to pi over 6 of the square root of 2 cosine squared x dx, which would turn out to be the square root of 2 times the integral from 0 to pi over 6 of cosine x dx, which would become... hang on, respond please. Why is it that every single time I do Control Z, it just lags? Square root 2 times sine x from 0 to pi over 6. Sine of pi over 6. Pi over 6 is, oh god, 30 degrees. So that's 1/2. 2 over 2. 45 is 1/2 square root 2. That is correct. Another easy problem for us. Up next then, we got our final challenger, number 47, which would like to know the indefinite integral of 1 minus tangent squared x secant squared x. Oops. Why did I do that? Secant squared x dx. I find definite integrals quite a bit easier than indefinite integrals. I mean, the other way around. I find indefinite integrals quite a bit easier than definite integrals. Because, well, the hardest part of calculus is actually algebra. You take out algebra and then suddenly calculus is easy. It's all... we have so many steps in the algebra question. You're bound to get one question wrong. But let's see if I can rewrite this. What do I do? Do I rewrite secant squared x to 1 plus tangent squared x? That wouldn't really help, would it? Unless... no, I don't feel like it. Let's try to do this first. Tangent squared. Yeah, I don't have to do algebra. And algebra is the hardest part. So that would translate to secant squared x minus 1. Wait a second. So that would be equal to 2 minus secant squared x over secant squared x, which would be equal to the integral of 2 over secant squared x minus 1 dx. Rewrite that a little more. 1 over secant is cosine, so that's integral of... respond. That's the integral of 2 cosine squared x minus 1 dx. Alright, we can rewrite that. That is equal to the integral of 1 plus cosine of 2x minus 1 dx. So that is just equal to the integral of cosine of 2x dx, which is equal to 1/2 sine 2x plus c. Did I write plus c for the last... no, last problem was a definite integral. We didn't really need plus c. And that would be... this is 47. Is correct. Fantastic. That was a lot quicker than I expected, but Microsoft Whiteboard has decided to freeze itself again. We have now completed textbooks chapter 7.2, 7.3, 7.4. Trigonometric integrals, trigonometric substitution, and integration by partial fractions. And that is all I have for today. I'll be here again on Saturday. Normally, our calculus streams are always on Saturday. But then last Saturday, the peripheral I'm writing with decided to break, so I had to get a replacement and I couldn't do it. So that got delayed and split into 2 parts yesterday and today. Next, or rather this Saturday, we will have 7.5, 7.7, and 7.8. There's no homework for 7.6. That means this Saturday we're gonna finish up with chapter 7. Alright, thank you everybody so much for sticking here. I'll see you next time. Have a good sleep. You wish you had these streams. I know one of my friends suggested that, hey, why not go teach as a VTuber? I was like, yeah, you know, that's quite a good idea, but I don't know if I would actually qualify to teach. But it was good to see you. I'll be here on Saturday. We usually do like 5 hours of math straight. But thank you guys so much for staying here. You guys are awesome. I'll see you next time. Sounds familiar. There's people teaching math everywhere. We don't have to worry about math dying down. Even on some very explicit websites, there's people teaching maths. Math is truly everywhere. Alright, good night everybody. Have a good dream.